Hi everybody, once again this is Talking Digital Industries with a deep dive on exciting technologies which drive digital enterprises, brought to you by Siemens. I'm your host Christine Brunner, and in today's episode we'll talk about what I'd like to call an oldie but goldie, as the hero of our podcast is turning 60. Yes, 60 years supporting and enabling to make not only production but also our lives easier. CNC controls have fundamentally changed production. Without them, no machine tool. Without machine tools, no cars, no smartphones, nothing more or less which is being produced by machines. For 60 years, Sinumerik has been contributing to this. And since 60 years, quite a lot has changed. What initially started with punched tape nowadays is digitalized all the way. So instead of paper tape, a digital twin delivers all necessary wisdom and knowledge. Talking about wisdom and knowledge, with me today are two experts from Siemens who truly stand for this. I am very pleased that Ankita Kambale and Karsten Schwarz are joining this podcast to share their expertise with us. Ankita, let's start with you. Can you please introduce yourself to our audience and share how it all started for you?
Thanks, Christine. My name is Ankita, and I'm pretty much a newbie at Siemens. I started my journey with Siemens about 3 years ago at the Machine Tool Systems division here. And since a year, I have been working as a promotions manager for a new system called as Sinumerik One, which is a brand new member of our Sinumerik family, that I'm sure we will be discussing about during our podcast today.
For sure. So we're looking at 60 years of Sinumerik and an intense friendship of 3 years for you, Ankita. And Karsten, we are curious now, how deep is your relation to this legendary control device, and what is your story within Siemens?
Yeah, hello, Christine. My name is Karsten Schwarz, and I've been working for machine tool industry for more than 35 years, and with Siemens machine tool for 30 years. Open speaking, when I was young, I had a lot of doubts whether mechanical engineering was really that what I want to do all my life. And I had a lot of respect for these complex machines and could not imagine working in this industry. Looking back today, I have never regretted the decision to work directly in the machine tool industry after my engineering studies. I started my career in 1985 at the machine tool manufacturer Heckert in Chemnitz. Yeah, it was the first time I understood the exciting world of CNC machine tool manufacturing, and to this day, the enthusiasm for this has never left me.
This is brilliant, Karsten. And it's nice to hear that even though it was not love at first sight for the subject, you're still all excited about it. So, Karsten and Ankita, where did you get in contact with CNC for the first time?
My first contact with Sinumerik was during my time working for machine tool builder Heckert, who is one of our Siemens customers until today. Depending on the customer requirements, we have installed different control systems, but very, very often Sinumerik. This is related to the fact that Heckert machines supplies in the automotive industry, where Sinumerik was and is preferred.
And you, Ankita?
This is a question I don't have a definite answer to, but I would love to share my thoughts about it. So I come from India. So back in India, when I was doing my bachelor studies in electrical engineering, so we did have a subject called as control systems. So that was my primary contact. But back then, CNC was nothing more than computerized numerical control to me. But by now, since I'm working with Siemens, which was apparently by accident then 3 years ago, working with machine tools, and then literally over 3 years getting fascinated by the technologies. And until now, I'm still around CNC.
All right. I suppose we're all ready and eager now for the deep dive into the treasure box of Sinumerik. Karsten, can you quickly explain to our listeners, what does a CNC actually do?
Yes, I will do. First of all, CNC stands for Computerized Numerical Control. Simply explained, very simply explained. This is a computer that controls a machine. e.g. a milling or a turning machine. The main purpose of a machine tool is to manufacture a product from a raw material, like a block or round material, with the help of cutting tools. Probably all products we use every day have come into contact with a machine tool at some point. For example, the shape of a hairdryer, the gearbox of a car, or even a knee implant. We could say that manufacturing with machine tools is the backbone of the world.
Wow. That is quite a statement, Karsten. And you sound very convinced about this.
Yes.
So, what is most fascinating about CNC for both of you?
So maybe I can go this time. This is a funny story. As an Indian living abroad, I'm often asked that I must be a software developer. Now that's the time when my pride kicks in and saying, sorry that I don't fit in that stereotype. I work in the field of automation and specifically CNC automation. It doesn't surprise me when someone has no clue about what this apparently means. That's when I start explaining the facts that how our livelihood depends on the CNC machines, how just Karsten just explained. So it could be high performance car engine or a luxury watch or a dental implant or as simple as a coffee machine, wherever it involves making something usable from a block of metal. So that's the most fascinating aspect about CNC to me is the degree of complexity and the depth of technology that goes behind production of these everyday items. As a consumer, we barely appreciate the impact of machine tools in our everyday life. It is as crucial as internet in our lives, honestly. CNC machines are the underdogs of our society, what I believe in.
There is love in the air, I can tell. So, Karsten, what about you?
Yeah, often it is like art, what the combination of high technology and good skilled workers are able to do. This surface quality, this shape and everything is fascinating. But on the other hand, metal cutting often has a bad image, especially amongst young people. Many believe this is a dirty and monotonous job. It is quite the opposite, believe me. Today, there's a lot of space for creativity and new ideas. But one project in my long career has impressed me the most. 10 years ago, I led a project called Metal Meets Medical. The goal of this project was to define the needs of medical industry, especially in the fields of the production of implants. I learned a lot there, believe me. And I understood how modern CNC technology lays the foundation, for example, for people to remain mobile when they are older and older, like me. Even in old age, people can continue to realize their dreams, run a marathon, climb a mountain, or walk the way of St. James. A broken hip or a knee is no longer an obstacle. And only CNC technology has made it possible to produce these implants today in an affordable and high quality and high volume.
Wow, this really is impressive. What a relief for so many people suffering.
Yes, for sure. Sinumerik is a part of medical industry. For example, the knee implant. The requirements are so high. When climbing is there, up to 10G acceleration on one knee. Therefore, implants are made out of very hard material and very expensive material like titanium. To cut this material, you need good machines, perfect controls like Sinumerik is. On the other hand, the surface quality has to be perfect. No additional friction between implant and bone is allowed. So it is an expensive production, and on the other hand, you need reliable technical solution.
Really fascinating facts, Karsten. I had no idea. So, 30 years, your heart beats for Siemens machine tools. We celebrate Sinumerik's 60th birthday this year. Do you actually know how it all started?
Yes, I know. In 1957, there was a first installation of a numerical control milling machine at the US Air Force in their own workshop. In 1960, Siemens already started to equip a Pittler turning machine with the first NC, without C. Be careful. And from 1960 to 1970, Siemens produced thousand pieces and of these NCs only. So in 10 years, only 1,000 pieces. And 1964, this solution was named Sinumerik. But the real starting point of mass production was 1972. Siemens established a factory called GWE, and this was the foundation for mass production of NCs. In the middle of the 70s, Siemens added the computer into this NC, and since then up to now, we speak about CNC.
Wow. So it sounds like a lot of manual work. You mentioned 1,000 pieces within 10 years. Just to recap that once more, 1,000 pieces only within 10 years. Was there no need to produce more, or was it so complicated, or why didn't we produce more than this very small amount? We were acting on a global market.
Yes, but in this time, it was hard to use outside of automotive or aerospace industry. And you needed very good stuff. Everything was done by hardware, by special knowledge, no comfortable functions for the user, no usability of the controller, everything.
That really is a development within very few years. So, Ankita, what is it like today? Can you share some knowledge on this point?
Honestly, thanks to the technological advancements all these years and the great minds who drove this evolution all this time. I mean, historically, Siemens has been a contributor and an innovator to our industrial society. I mean, we have come a long way from NC to a digital CNC. So last year, we launched our newest and smartest member of the Sinumerik family called as Sinumerik One. Now, with Sinumerik One, Siemens breaks new grounds in many ways. So it's not just any usual upgrade of previous CNC system, but rather undoubtedly the first digital native CNC that makes the interplay between the virtual and the physical sphere perfect and seamless. So Sinumerik One honestly is the living proof that we are technically digitally transforming our machine tool industry.
No doubt. Digitalization is bringing lots of advantages and enables us to walk bigger, faster, and more efficient to incredible unknown territory easily, for sure. Karsten, how was it for you working with Sinumerik when you started your career?
Oh, when I started in the middle of the 80s, it was a big difference how to handle a CNC compared to today. Let me describe the process how to program a CNC workpiece program. I had a drawing of the requested customer workpiece on my desk, surrounded by some Sinumerik programming manuals. By hand, with a pen, I wrote word by word, sentence by sentence on a sheet of paper. In the next step, somebody like a secretary wrote this program with a device similar to a typewriter. This machine created the so-called punch tape. The punch tape roll sometimes had a diameter of 30 centimeter or more. With this roll of punch tape, I walked to the shop floor directly to the target machines. There, I put it in a reading device, and the information was read into the controller.
I imagine you walking around with heavy paper rolls. You did not need to go to the gym, I guess. Seems like you weightlifted whilst you were doing your job. But what happened when, for example, the punch tape got lost or it tore?
Oh, yeah, that was always an adventure. Sometimes by mistake, the punch tape fell down and there was oil or cooling on the floor, and this is normal in a shop floor. And then you couldn't use the punch tape anymore. Or there was a typing mistake on the punch tape and the process stopped. Oh my God. Then you had to walk back into the office and to try to find out what is the mistake, which caused the problem. And this was always there. It's difficult.
Wow, for sure. We all appreciate the smooth and easy way of working and producing nowadays. But how exactly does this technology work today? To what degree has it evolved?
I mean, the punch tape would be a nightmare today, right? But I'm sure programming a CNC back then and now is equally demanding and requires profound skills, which means the programmer has to be someone very specialized in that field. So today, as everyone knows, CAD/CAM software plays a very crucial role, which gives manufacturers more control than ever to design and produce intricate workpieces. If anything, the introduction of CAM software has entirely revolutionized manufacturing. So CAD allows you to create a 3D model of the workpiece to be manufactured, and CAM uses numerical control to create detailed instructions, which we call G code in our CNC manufacturing, which drives the CNC machines to produce the desired part. So for testing, I don't even need the real machine. But with the digital twin, I can securely test and optimize it right from my desk, from my PC.
Yeah, I guess Karsten would have had to produce lots of kilometers of punch tape to come that far that quickly.
Yes, around the globe for sure.
Yeah.
And another funny thing is when I remember the memory size. In this time, we spoke about 8 kilobyte maximum memory for CNC. Today,
To
I
quickly
think,
jump in here, Karsten, this is like the sound chip on a birthday card, I guess.
yeah, yeah, that's it. That's it. In case of a huge part program, you face the next problem. There was not enough memory available to upload the program. Compared to the possibilities today, it was really tough to write a CNC program in those punch tab days.
Wow.
Yeah, I mean, today it is much more than this, right? I mean, if you see, the goals of CNC technology are still the same, which is you demand increased productivity. You need to minimize the downtimes and detect failure more efficiently. But over the time, the machines have grown to be more complex with multitude of machine parameters that produces a huge amount of data. So to countermeasure this data, it demands smarter analytic tools and software and stuff like that.
Talking about amounts of data, the digital twin also produces or generates vast amounts of data. But nowadays, the digital twin is an elementary part of the control system, right?
Absolutely. I mean, the immense potential which the digital twin carries are boundless. Now, just imagine, even before a real machine starts working its magic to produce high end parts, with the digital twin, you can virtually develop, test, optimize, and validate your machines way ahead of time. So, as a result, the machine builder is able to tremendously reduce the time to market of his machine. Moreover, the machine builder can make the digital twin accessible to machine users. Now, with this, I mean the machine builder suddenly does not just sell the machines, which is the hardware, but also sells software, which brings this added value to the customers. For example, through digital self optimization tools or predictive maintenance tools for reduced and planned downtimes, and so on and so forth.
And what do our customers say about the use of the digital twin?
So, as I mentioned earlier, we are in the middle of digitally transforming our machine tool industries, which is apparently quite a traditional one. I mean, you would agree that any new transformation brings along a sense of resistance and skepticism. Many of our customers do resonate with our vision of digitalization and push innovation. However, many customers are gradually embracing the trend because they're recognizing the ever growing market demand, which is speed, flexibility, and the high degree of customization. And digital twin is a key to overcome these challenges.
Mm-hmm. Karsten, do you think it is more complicated today? Can you relate to this? Like, did you also experience some resistance, for example, regarding changes or new ways of doing things in the past?
Yes, yes, I can only agree with that what Ankita said.
Mhm.
Another example is approximately 5 years ago, we start to offer touch panels to operate the Sinumerik machine tool. Many people, like me, had doubts about using touch devices in a dirty environment like metal
Mhm.
cutting factories often are. But today, we will find no new machine without touch operator panels, and surprise, it works fine.
Mhm. I mean, our life is not imaginable anymore without touchpads. Our cars, our phones, everything,
Yeah,
of course. So,
yeah.
is there a certain industry who is a key user of controls? I mean, markets change, requirements change. How is the situation now?
Okay. Yeah. Automotive, aerospace, as I told before, first. But in the 90s, Siemens started also to bring Sinumerik into the job shop area.
Mhm.
Today, Sinumerik is part of the mass market, and especially small customers like our usability and the functionality of our control. But this was a long way and the hard work. One important step was to build up the worldwide network of the DEX, stands for Digital Experience and Application Center. This network is a huge communication platform with possibilities for training and presentation on real machine.
So, Ankita, has that changed with Sinumerik One?
Well, this approach has certainly not changed, rather enhanced, I would say. I mean, we as the electrical equipment supplier in the machine tool industry lay equal emphasis on the machine builders as well as the machine users. Hence, the digital twin of Sinumerik One has two perspectives, one for each. With the digital twin of the machine, the end user can experience benefits through virtual job preparation or offline programming or process optimization. In addition, virtual training enables the machine user to get hands-on experience with the machine with zero risk of damage to the machine itself and the workpiece, of course. So, and not to forget, the real machine is fully available for production while others are getting trained on the digital twin, right? So,
Yes, that's so much better than walking around in the shop floor with a punch tip.
And weightlifting, yeah, for sure. Well, time flies, especially when talking about a great adventure which already lasts for 60 years. This is really super cool talking to you. For sure, there is much more on our discovery map in the future. Thank you so much, Ankita and Karsten, for your insights and anecdotes. I really enjoyed this episode with the two of you.
it was a pleasure being here. Thank you for having us.
Yeah, thank you. I appreciate.
Really cool. We could talk on and on. And dear listeners, if you're interested in more stories about the history of Sinumerik, just go to siemens.com/Sinumerik-my story. Thank you all for joining. Stay curious, brave, and healthy. Bye-bye, and all the best from your Siemens Digital Industries podcast team. Stay tuned. Much more to come.